Hello, TMXers. My name is Vincent from the mobile mapping support team, and I will present to you what's new in TMX 25.3 Part 2. In this presentation, I will highlight the changes in the UI just to help you easily identify what has changed. And I will show you new tools, the new tools and the updated tools, and the focus will be on AI-related workflows. So if you open Trimble MX, you will notice and check the main toolbar, which is on top of the software. You will notice a new button here. It's called Upload. And this upload basically contains the local catalog. So you can see also that the local catalog, which is now under the upload, it was under manage. So basically, local catalog was moved from manage to upload. You will also notice from the resources menu a new option. It's add multiple generic resources vector, which allows you to select a directory and it will load all the vector files contained in this directory. In the preferences menu, there were a couple of changes. I highlighted in red the things that were removed, in orange the things that were updated, and in green the new things. So basically we first can notice on the left is 24.3, it's the previous version, and 25.3 on the right is the current version. So analysis engine was removed from the preferences, and now basically the AI detection preferences are all under the AI detection preferences. We now have a new preference, it's annotation classes, and tags were they were updated. Let me show you the differences a bit later. So yeah, in preferences annotations, preferences AI detection, you can see, so this is in 24.3, the analysis engine preference was deprecated. We already had AI detection preferences. This is, by the way, where you could see the currently installed version of the analysis engine. And this is where you could select the folder containing your detectors. Now the AI detection not only shows you the currently installed analysis engine version, but it also shows you the minimum required version of analysis engine. And you can also, now from here you can open the tab to, it will open the AI library tab where you manage your detectors. So your detectors are no longer managed from here. They are managed from the AI library tab. And the AI library tab is new. And this is where you can manage your detectors. I can show it to you. So let's say it's here. So AI library. And it contains the detectors that I have on my computer. If I press open local library, I will see all the detectors I have. So if you receive a new detector, you want to put it in this folder. Make sure it's unzipped, and then simply press the refresh button to reload it. Preferences tags has been updated in the way that the image annotation is no longer available. Why? Because this was replaced by annotation classes. So again, it's something in the preferences, annotation classes. This is where you can define your classes. There were changes also in the tools menu. So we have those three new tools: compare vector datasets, create geospatial index, create point cloud from vector. These two ones, Artem already presented them in the part one. Convert objects to 3D, it's just a small update. It's now it has now two more output options: 3D areas from center point and 3D areas from areas. I'm not gonna show it. Compare vector datasets, it's a new one that I will show later. Changes in the manage menu. So we already talked about the local catalog, which was moved into the upload menu. Trajectory was renamed the trajectory adjustment. and delivery was updated. And I will show right away what this means. What's the update in the delivery tool? So delivery now allows clipping the mapping resource by AI labeled images. So there are two benefits to that. First, it's easier to get a resource which is completely annotated. Remember that when you train your data for AI, when you prepare your data for AI training, it's important to be complete and consistent. Complete means all the objects that you want to train for your detector or that you want to feed to your detector must be annotated. If, for example, I want to classify a data set to detect road signs and I miss a couple of road signs, the AI training algorithm will see this road sign and it will think it's a road sign, and then it will compare to the ground truth that you provided, and the ground truth will say no, it's not a road sign. So then it will confuse the algorithm and provide a less good detector. So it's by clipping by AI labeled images, it allows you to remove the images that have no annotations. And it will also allow smaller file transfers. So let's say you have a big mapping resource and you only annotate a small portion of it and you want to use that portion for training, then you don't have to send a whole mapping resource that's like 100 gigabytes. Let me show you how this works. So I have a mapping resource here. It contains a couple of annotations. So let me open the panoramas and zoom to that asset extent. So this is the mapping resource. I can show the point cloud as well. It's not very easy to see from there. But yeah, it's a mapping resource with point cloud and images. And it also contains a couple of annotations. So if I go to extract photo image annotation editor, something you should know, you can see that there are images with annotations, only 4, okay? Let's say that I want to use that to train my AI detection. It's not enough, of course, but it's just to show the delivery tool. So now I will go to manage delivery and I will make a new delivery. And now local catalog list. So I can right click on my mapping resource, just as usual. Add to delivery. Where is it? Add to delivery. Now you can see the little D on the right. And for clipping, I will select clip by AI labeled images, and then I can select image with 2D objects. Those are the 2D boxes, and 2D segmentations. It's like polygons, free polygons that you can make in your images. I will show that later. And you select the target directory. I'll use my dtemp because I know I can delete it later. Give it a name. So I'll call it 826 MX9 clip. Okay. And then you can choose what you want to copy. So vector image is only the original, and point cloud, you want to process the point cloud. I'm not going to process it, just to make it faster. And start now. So it was pretty quick. And so it opened the folder containing my resource. You can see the size. $16 megs compared to a couple gigs for this whole resource. And I can load it here and you will see it's only covering a small area with only a few images. Yeah, the 3 images containing the annotations. Okay, so that's it for the delivery update. There were a small change in the local catalog. The additional content column, it was already there in 24.3, but now it's been slightly changed. In the past, we could see context scene. Now context scene has been replaced or renamed by checkpoint. A checkpoint is simply a file that describes the classes used in the image annotation or the classified point cloud. It can be created by right-clicking on the resource, generate data, create annotations checkpoint. In the past, it was called image annotations to context scene. So the name has changed a little bit. But more interesting, it also shows you if your mapping resource contains annotations. So even if you did not generate your checkpoint, it will show if you have annotations, image annotations. Now, about the extract menu, there are a couple of changes here as well. So this is 24.3. Point cloud change detection has been renamed to compare point cloud to point cloud v1. It's exactly the same tool, but now there's a second version of it, compare point cloud to point cloud v2. This is a tool that Artem presented in part 1 of this webinar. Beyond that, there are new tools: AI evaluation, AI library, point cloud annotation editor, compare point cloud to design that Artem also presented. And there are some updates in AI detection, image annotation editor, and clearance checker. Let's start with AI library. So AI library is simply an extension here. So AI library, it basically shows information about the selected detector in your AI library tab. So that's it, short and quick. The next thing I want to talk about is clearance checker. So clearance checker, there is a minor update here. It's in the advanced parameters. You have these 3 new options here: validate ground, tolerance, and thickness max. Basically, these are parameters that allows a better ground validation and ultimately having fewer incorrect clearances. So for example, if the ground is too irregular, if there's a car, for example, it will detect it and it will not calculate clearance from that area, or will calculate it correctly from the ground. Okay, now we're going into let's say the core topics related to the AI detection. I will start with AI detection in point cloud, and to show the new tools and updated tools, I will use a workflow example. It will allow you to review also other tools that are quite useful in the entire workflow. So I will start by classifying point cloud for AI training. And as an example, I will I will train or classify guardrails for a guardrail detector training. Okay. So here are the steps summarized. So first, I need to define the classes, create an asset resource, extract my vector objects, use point cloud annotation editor to automatically make the point cloud selections. This is new. Then I put complete selections manually just to make sure everything is clean. Use point cloud selections to classifications to convert selections to point clouds, and then send those point clouds to Trimble to MX support at trimble.com. This is us, so we can train the detector and send the detector back to you. So first, defining the classes. So I have to check my data set, what kind of guardrails I had. These are basically the 4 types of guardrails I could find: W beam, tri beam, box beam, and round beam. And I made my classes here. And I also kept a class for not selected, just in case I forget to enter the class. So you see, I went in my annotation class preferences and created a new, I can show you here, preferences, annotation classes. So this is my class. I don't know why the display name is not kept, but anyways, let's say I want to create a new one, guardrails 2. Just enter a name here, press plus, and then enter your labels. So it could be, I don't know, stop sign plus speed limit, okay, for example. And then you can also add description in every of those. For some reason, not sure if it's normal, but whenever I change and come back, these descriptions go. It's not the case for all of them, but anyways, and you can delete those and delete the entire annotation class group as well. Okay, so anyways, this is my classes for the guardrails. Next thing, I created an asset resource, and I also added an attribute to allow me selecting the class. And in this attribute, I created a value list containing the classes. So I want the class to be a number, and here's the label for my classes. And I also created a custom formula in the ORD file to automatically assign the height and width depending on the class. Okay, that might sound a bit complex. It's in fact not so easy at first glance, but let me show you. If I go to my local catalog generic resources and show you my my asset resource, it's called guardrails. Here it is, and I will open the attribute table and show you something. So you can see, for example, the width and the height, they depend on the type. Okay, and how did I do this? Let me open the folder and show you the ORD file. So in this ORD file, there are things that were created automatically by the software. For example, here, the value list, okay, attribute name type, rule value list, okay, and here are my selected options or selectable options. And here, these are rules that I created myself manually in the file. I forgot to say, but I had to add those attributes. So width, height margin, enter. I added them from here. So from the structure of the resource. Okay. With they have a float type. Okay. And once that is done, I went to my ORD and added these formulas. So it's a bit complicated to explain like this, but it's just an if and equal. And if you want to have more details about how to create specific customized attribute formulas, you can open this page here. Okay, you can see the link here. And here you have information about all the possible functions that can be used in the ORD files. So basically, what my formula does, it determines the value of the height. This formula here, okay, determines the value of the height. If type equal 2, height equal 0.3 meters. If types equal 3, this is the tri-beam, height equals 0.5. If the type is anything else, height equals 0.2. And to know how the dimensions of my guardrails, I opened a vertical slice view perpendicular to reference, and I used the measure function to determine these dimensions. So this is what I used in my ORD file. Okay, now that my asset resource was correctly set up, I started extracting guardrails. So I used a lot the guardrail detector. By the way, the guardrail detector is now available in the Create Asset Objects tool. It was not present in 24.3. Now it is available, but it's also available in the normal measure toolbar. So I used guardrail detector. I also used slice view to pick the top of my guardrail. I use different methods depending on the situation and the type of guardrail. So at the end we have something that looks like this, and you can see the color changes. So in this pale yellow it's box beam, in purple tri-beam, in clear blue it's W beam. Okay, so it's important to carefully select the correct class in order for your data to be consistent. So complete means you need to select all the guardrails, and consistent means you need to always select the correct class. Okay, then once I have my lines, I want to convert those lines into point cloud selections. And there is a new tool for that. It's called Point Cloud Annotation Editor. It's from the Extract menu. And it works with a project. So when you open it for the first time, a project will be automatically created. You can create a new one. You can open an existing one, delete it. And then what I did, let me show you here. So I'll do a short example. I will open a small mapping resource containing guardrails. So this one, and I'll zoom on it. Okay, so here I've got a small mapping resource with my guardrails. Okay, I go to Extract, Point Cloud Annotation Editor, and then it creates a new project. You see, you can create a new one, open, delete, close. And then I need to select the polylines. Okay, and to select all my polylines, I just select my guardrails asset resource, select polyline here, press add. Now all the objects will be added. Note that here there is an option, create selection. You can select an attribute, but the value needs to be, let me show you, it's documented. So if you go to Point Cloud Annotation Editor, you will see the explanation. Create selection. So it needs to, it's an attribute, and the value should match one of these values. True, false, 1, 0, yes or no. Okay, so it will mean if it's basically if it's true, 1 or yes, the object will be used for selection, otherwise it won't be used. But I didn't use that method. Instead, I want to use all the lines and I always, in my selection method, I don't select a parameter, I just directly select 3D rectangular here. And for the class ID, I use my type attribute. For the width, I use my width, which is automatically calculated. So you can see, for example, if I select 2 guardrails here, you will see that the width is different. So this is, it's hard to see, but this is the box beam. You see the width and the height is different than the tri-beam. Okay, so I don't have to use a specific constant value here, or it's a use parameter. I can enter a constant value here, but instead I used the values from my attributes. Height margin also, it's always the same in my resources, but I created the attribute so I can use it. And now maybe I can explain a little bit those parameters. So you have 3 possible entry positions: middle, top, or bottom. The entry position, it's like where the box will follow your line. So if the entry is in the middle, you can imagine the box that will follow a line, and the line will always be in the middle. I personally use top because I've made my line on top of my guardrails. Height is simply the height. If it's middle, it's the total height of the box. Now it depends where. I mean, if your anchor is on top, it will be below this. The height is completely below. Uh, the width is the total width of the box, and the height margin is just an extra height you can add. It's always both up and down. Okay. So that's it. Then you just press start now. So let's do it. It's done. Now I can view results. By the way, project preferences display features only shows the objects that were used to make the selection. Now, if I select view results, it opens the 3D point cloud selection tool. And then if I select a class, it shows me which class I have. I can manually fix it if I'm not happy with the selection. So I can, for example, what I like to do is hide the data outside selection, and then if I want to remove the ground, I'm going to use, for example, the brush and select here remove. Careful to not replace, because if you replace the entire selection, and you will have to start point cloud classification to point cloud class selection editor, point cloud annotation editor again. So let's say, yeah, I'm happy with that. I can switch to the other one. Check them all, okay, and review them. So, and the changes you make here, they are saved on the fly, so no need to save anything here. Okay, so once you're happy with this, let me come back to my slides. Yeah, here, final adjustments. Okay, so, oh yeah, here I forgot to mention, I did a lot of let's say back and forth adjustment to fine tune the height and the width in my ORD file. So I run the point cloud annotation editor tool, check if the objects were properly selected. If not, I just adjusted my parameters, run the tool again. Okay. So that's something you can do. It makes it quite efficient, because if you have a lot of lines, it's really long to manually fix the classifications, the selections. And I said finalize with manual selection. Here I show a slide giving some tips about that. And once you're happy with your selection, you can convert point cloud selections to classifications. So from the point cloud annotation editor, click create classified point cloud, or you can open it via tools, point cloud selections to classification. So let's do it. Now I'm in the point cloud annotation editor, and I can create classified point cloud. By the way, there's also open directory. If I open it, it shows the directory containing the OPS files. OPS is orbit point cloud selection. Anyways, now you go to create classified point clouds, and it automatically selects the source point cloud and the source directory. If you open it directly from tools, these won't be selected, so you have to select the point cloud manually in the folder manually. Method, you can do entire source area or multiple areas. So these are the classes that were detected in my selections, and it will here, this is the target. Okay, so class label, we can use OPS name or class code. Let's see what it does. Start. So I'm basically converting the selections to classifications in my point cloud. Okay, it's done. So that's it. The point cloud has been loaded automatically here. Point cloud classified. And we can, let me just show you here. This is the original point cloud. If I go to Legend Editor classification, it's all green. It's all white. So it's not classified. It's all default class. By the way, you can close the selection here. If I go to Tools, 3D Point Cloud Selection, you can just close a project. Here we go. Okay, so this is the point cloud that was classified. If I right-click Legend Editor and select Classification, we can see that it contains some classes. By the way, these classes, you can change the color if you go to Dataset Properties, Classes. So you can define the color for each of them. Let's say I want something like this, and maybe I can change the class values also. Class 1 is default. Class 2, I remember it was W-beam. Class 3, tri-beam. In class 4, I think it was box beam. Maybe I should be more careful about that, but I'm pretty sure it's the case. Okay. And then if you right click on your resource, show legend display, you can see here. Okay. So yeah, now let's move to the next step. This is done. This is the result. And once you have your classified point cloud, you send it to us via mx_support@trimble.com. That will open a support case, and we will generate an AI detector from it and send you this detector back. Then you will use AI detection. Here there was a small update. So the change is that now it requires the version 25003 for the analysis engine. And some detectors made for previous versions won't work and will need to be converted. If it happens, simply send the zip detector to us via our email address. Let me show you an example of a detector that doesn't work anymore. So those in red here, you see if I hover over it, it says AI detector is not compatible. Please synchronize your AI library. It should be green like this. Okay, detector available for AI detection. These ones are old, you can see the date. Okay. All right, next. AI detection result. So I already created an AI detector for my guardrails. So let's give it a try now. So I can just remove this point cloud from here, show back the original point cloud, okay. And I'll go to extract AI detection, select my reality data, and choose resource type. It's a point cloud, 3D segmentations, and here's the only detector I have for point clouds. And then method entire source, just start now. Again, it's a project, so you can create multiple detection projects inside the mapping resource. So I will pause while this is processing. Okay, processing is done. I'll put 4 classifications, and we can open the directory that shows the project directory. And what else can we do? We can also evaluate AI results, but first, let's see what we now have. We now have this new point cloud and this new lines 3D. So this new point cloud is simply a classified point cloud. Again, I can check the dataset properties, classes, and you see the classes were correctly selected. That's because of my detector. My detector contains the classes correctly named, labeled. And the second output is the lines 3D. So it creates lines along the linear classifications. Okay, so it's also good because it automatically extracts line objects. You can see, for example, what are the attributes. It gives you the label info, the label ID, which is a class, and the length, and so on. So yeah, that's the result. Now let's see AI evaluation. So when you press evaluate AI result, it will open this tool. That's a new tool, and it compares the AI detection result with a manually annotated or classified resource considered as ground truth. So for source, you need to select a mapping resource having a completed AI detection project. And for AI detection, you select the completed AI detection project in this mapping resource. And the ground truth will be selected automatically. It's going to be, if you select a 3D segmentation detector, it will select the point cloud from that resource. And if you select a 2D segmentation for images, it will select the images, the annotated images. So let's give it a try. So here, yeah, I go to evaluate AI results. And now I need to create annotations checkpoint. You see the AI detection project has been selected automatically, and it recognizes the type and the detector. And I will create the annotation checkpoints because it needs that. It's basically describes the classes used from the detector. And here it says link AI detection to ground truth. Why is that? It's because the point cloud linked to my mapping resource is called point cloud, and this point cloud is not classified. That's why I need to replace it. So I will go back to my local catalog, or let's say here, inspect open file location, and I will turn this resource off because I will make some changes. It won't allow me making changes if the resource is open. So that's the folder. And if I go to point cloud, this is my original point cloud unclassified. This is the one that was classified manually or using point cloud selections to classifications. What I need to do is basically rename my classified point cloud to point cloud. So what I will do, I will just, let's say, first rename this one to original. And here I will rename this one to just remove classified. That will become the ground truth. Rename this file as well because it's describing the classification colors for this point cloud. Okay, so now I will reopen this resource. And I can select reality data. Do I need to create? Yeah, now I create the annotations checkpoints. And when I do this, now it recognizes the ground truth. And it also automatically links the classes together. So the classes are mapped automatically, but if there's an error, you can select them. Here you see there's no round beam in my classified in my AI detection results, so there's nothing to select here. Now I'll press start now. Okay, it's finished, and now I can check the results. So basically I can see 3 different colors. Gray is well, let's see. If I go to dataset properties, classes, we can see the different colors. So gray is default. So that was originally default and was classified as default with AI detection. You see the first name is the original class, and the second name is the detected class. So here in yellow, it's always wrongly detection when it's yellow. And when it's green, it's correct. So W beam that was classified as W beam, tri beam, and so on. So you can see in green this is what is correct, and in yellow this is what is incorrect. And you can also see a report. If I press open report, I can see a PDF file. It says label information. These are the classes available in my detector. Label precision is the percentage of correctly detected classes. And the confusion matrix, it says GT/P. So GT is ground truth. This is the column. These are the rows, and P, the columns are my project. So the result of AI detection. So for example, here I can see that here this number, it means that 11,000 points that were originally classified as tri-beam were classified as W-beam. That's pretty much it for AI evaluation. By the way, it can also be used on images. I'll show that later. Once you've done that, you can run compare vector datasets, because you have your original asset resource. Okay, in my case, it's my guardrails that I manually extracted, and I want to compare the result of AI detection, the result that was converted into polylines. I want to compare those polylines to the original polylines and see how good they are. So that's a new tool here, compare vector datasets. And as it says, it compares to input vectors dataset. It works with points, lines, and polygons. Here talking about the parameters, we have spatial match. Spatial match, you have two options, 2D and 3D. So 2D basically only compares the XY distance, and 3D takes the XYZ distance into account. And the 3D is only for points. There are some other parameters, intersection mix, min, and non-intersection max. So basically, intersection min is the minimum intersection percentage in the source. So if the source and compare resource just partially overlap by more than 50%, they will be considered as matching. If it's less than 50%, they will be considered as different. And non-intersection max, it's like the opposite. So it's the compared data set versus the ground truth, or versus the source. And if you have more than 50% non-intersection, it's considered as non-matching. Distinct attributes, you can select those. If the values of the selected attributes don't match, the object will be considered as distinct, not matching. So let's give a try here with my extracted lines. So I will go to, I think it's in Tools. I go to Tool, Compare Vector Datasets, and as a source, I want to compare the line. So I have to open my AI detection project. And here I have my lines 3D. Okay, so I can now go to Tools, Compare Vector Datasets, Source, it could be this file, and compare, I can use my guardrails. And then if I want, I can also use distinct attributes. For example, source attribute would be label ID, and compare attribute would be type. And then I can press start. And now I have my result. Line 3D compare. Well, let me open the attribute table to show you. Basically, we have the attributes of both data sets combined, plus these attributes here, eval intersection, and eval hard to see. Anyways, non-intersection. So what's interesting here at first is eval. Okay, so we have D1 underscore D2, and D2. D1 is dataset 1, it's the source. D2 is the compared dataset. So when it says D1, it means that this line is only available in D1. D2, it was only available in D2, it was not matching. And D1 underscore D2, it means that it was matching. It's both in D1 and D2. So if I show it here as different colors, I can go to my legend editor, classes, and select the attribute eval, then select classification, and I will select unique values, and I can color my lines with different colors. So D1 is incorrect because it means the line is only available in the source data set. D1, D2 is okay, so I can, let's say, I'll use a green color, and for D2 I can use a blue color like this, whatever color you choose. Okay, and now I can see my lines. So here my lines are green, it means that they were present in both, so it means the result was good. The red lines means it was only present in my source, so this is my detected, and the blue line is where it was present only in my compare data set. There are some attributes also that could be interesting. If you go to, again, to the attribute table, those attributes here, so the first one, eval intersection, it's the percentage when the objects are matching of the original or the first data set that is covered by the second one. Here it says 54, and here it's the percentage of the second data set that is not covered by the first one. So maybe my slides can be easier to understand. You see D1, D2, and then the comparison. So basically here it means that this line here was covered by in 99% by the D2, and this one 20% of D2 was not covered by D1. And I said it works with points, lines, and areas, so I just made some screenshots to give you an idea how it looks like. Now, this completes the part for AI detection with point clouds, and I will now show you the new tools more related to AI detections with images. And again, I will show you an example of workflow. And this is the workflow I'm going to demonstrate, and there are a couple of new and updated tools in there. So my goal here is to extract road signs, okay? So in summary, what we're gonna do with this workflow is extract the signs mostly automatically, convert these points into annotations, send the annotated resource for AI training, then run the AI detector to automatically generate the annotations, and then we're gonna convert back these annotations into points. Then, if we want, we can compare the results with the original vector dataset. Basically, this is the entire workflow. So I'm gonna show you how this works. So first, I used traffic sign analysis to automatically detect my traffic signs. I did it on another mapping resource here. So I went to extract. Let me turn off my guardrails just to make it cleaner, because we're no longer talking about guardrails. Okay, so here's the mapping resource. I will also remove lines 3D compare. Okay, so this is my mapping resource. It has some road signs in it. So I use the extract tool, traffic signs analysis. So this is the result here. Okay, so I'm not gonna run it again. I have my detected traffic signs. Right click on my detected traffic signs, import as asset resource. I can keep it there. I'll call it A26 MX9. Detected traffic signs, format OVF. I guess the DGN can work as well. Okay, so now I've got my asset resource here. And now, just like I did for my guardrail detection, I will add an attribute for the class. So just create a new attribute, call it whatever you like, class is good. And here I will create a value list where I can select it. And here are the different classes I want to use. I want to match with my detector because my detector is already done. I'm not going to train a new detector. So I'm going to match these classes. So I've got road, maybe I can create a new one for please select in case it's not selected. Okay, my value list is created. I want to create my classes as well, so I will go to Preferences, Annotation Classes. They are already here. Okay, so it's fine. Okay, I can close my traffic signs and analysis project just to clear my desktop a little bit. Okay, and now I want to use verify asset objects to clean my asset resource. So basically add the missing asset objects, remove the faulty one, fix those, and also especially add the class attribute. So let's check this one. I will open the object inspector. I can pin it if I want to see both mobile mapping view and object inspector. So I want to check the class. Yeah, I'm going to change the order of my class to have it on top. So I will go here, structure, select the class here and move it up all the way to the top, so it's easier to select. Okay, so now I can select it. So there's no specific class for I can select, so I'll just use please select or select nothing. Okay, again I'll use verify asset objects and keep going like this. This is, let's say it's pass by, another pass by. Okay, I'm done reviewing my asset objects, and now what I will do, I will go back to my local catalog. I can unpin my object inspector. So I will go to my local catalog, mapping resources, and what I want is generate annotations automatically from my asset objects. So, sorry, I want to generate the snapshots for my asset objects. So I go to asset resources, right click on it, generate data, create snapshots, and then the height you can use the Z range, which was measured automatically by either the traffic sign analysis tool or this one, traffic sign with one click, and the width as well. And that's it. You have some asset preferences here. Focus position. Now it means where is the point located? Is it in the middle, top, or bottom? It's in the middle. Margin unit, it's to add on top and bottom of your, I think it's all around the rectangle that it's going to create. Overlays exclude. That's it, here we go. And I'm going to replace existing, so if there are already snapshots, I'm going to replace them all. And I will press start. Okay, it's done. It created the 401 snapshots. I can close this tool and I can have a look at my snapshots. Again, with verify asset objects, go to asset inspector, and that will show you all the snapshots for each object. These snapshots, you can create them manually if you prefer. You can use add mapping snapshot, zoom on the mobile mapping image and press, here, add mapping snapshots, and then it will add exactly the image that is open in your viewer. I'm going to delete it because it's not relevant. So if you're happy with your snapshots, then you can move to the next step. This time you go to, again, local catalog, but mapping resources, right click on your mapping resource, and you're going to edit the resource. First, I want to see something in my extract image annotation editor. I already have annotations. I'm going to delete them all just to show you that I'm going to create new annotations from these snapshots. So right click on your mapping resource, edit resource, manage image annotations, and here as a source you will select asset resource auto-generated snapshots, and there you can, this is something new. Okay, this tool is not new, but this is an update since the last version. You can select an attribute to automatically, well, to select a class from an attribute. This is quite useful. And then I'll press add. And as you can see, it annotated my images. Now I can open the annotation editor and see my annotations. So we can see the annotations it created. So you see here, oh, maximum 50 maximum speed limit. There is one missing here. I can add one if I want. By the way, the image annotation editor was updated. Now you can directly edit an annotation by using the handles. You can change the class by clicking on it. And you can delete an annotation here, and to create a new one, it's very simple. You just draw your rectangle like this and select the class. Okay. Another new thing I want to show about the image annotation editor is that you can also now create 2D segmentation. So 2D objects is for punctual objects like road signs, but you can also create 2D segmentations for irregularly shaped objects. So for example, let's say I want to define the region here, the neutral zone where I have my chevrons. I can use, again, I need to create my classes. So I already created the classes for chevrons, so I can use this one. And then I can use here select by polygon, so I can just draw my area in my image. Okay, I'll do it very quick just for the example. Okay, let's say I'm happy with that. I'll select the class. Okay, so this is a 2D segmentation class. But anyways, here, let's come back. I want to revise my annotation if I want. When I'm done, I will just close it. There are a couple new things also I want to mention about the image annotation sidebar. This time you see you can open the image annotation preferences and the annotation classes from here. Also, you can delete all your annotations. This is something new. You can focus on map. So let's say I select this annotation and press focus on map. The map will be focused on this specific annotation. Another update with the image annotation editor is that you can open the image view. So I select the annotation and open image view. That will open the mobile mapping looking at the direction of the annotation. And you can also do the opposite, which is also quite cool. Let's say I open the view looking at this road sign. I can select this checkbox, list only opened images. So that opens only the image, which is the annotation which is open in the mobile mapping view. Then I can see the annotations there. Okay, so that's it. Now I have my annotated mapping resource. Again, I can use manage, delivery, and clip by AI labeled images, but here I can see that my images are all annotated, so I don't need to do that. Let's come back to the slides. So AI detection with images, these are the things I covered. Again, generate data is not new. Generate data is again to create the snapshots. Manage image annotations is to import the snapshots as annotations. This is an update where you can select the class attribute. There were some updates in the image annotation editor. You can create segmentations amongst other things. So now I have my annotated mapping resource, and I can send it to mxsupport@trimble.com and ask them to use it to train a new AI detector. Then we'll send you back a detector. You have to unzip it and paste it in your AI library, and then you can run AI detection. So again, you go to AI library, open local library, you unzip the file, the folder here, and then you refresh and you'll have your detector. So let's run the detector. That's what you would normally do. Now I have a detector here. It creates a project. Let's create a new one. I can delete the previous project if I'm, and then create a new one. And then choose resource type, it's image, and choose the detector. Choose the method, press start now, and wait until it finishes. It can take a couple hours depending how long is your mapping resource. AI detection is complete. It added a new resource here, annotations. It's simply the photo positions containing annotations. Before I import these annotations into my mapping resource, I can again use a tool, AI evaluation. So here the mapping resource is automatically selected because it's open. I will select the detector. It's the detection project inside this mapping resource. That's the latest one. And for ground truth, I will choose a checkpoint I created, or maybe I can create a new one for my resource using the original annotations. Okay, so I'm going to use the latest checkpoint, and then I can again link the classes from my detector with the classes from my resource. So they are already linked automatically. And then I will press start now. It's done. Again, it creates a report. It shows you the classes available in your detector, the precision result in the detected classes. So we can see it's very poor because my detector was not appropriate for my area here. And again, evaluation details. This is the classes in my ground truth. It's the original annotations, and these are false negatives, false positive, and true positives. So I can see basically there was only 6 true positives. I'll let you interpret this table, this report. And we can also import as image annotations. So if I do this, it will open the edit mapping resource that you already seen earlier. It automatically selected the proper parameters. So it's an annotation files from analysis engine to the object evaluation. It's opening the correct context scene.json. I will replace the annotations in this mobile mapping resource. So the annotations that are currently there are those that I created with my snapshots. So replace. And then I can see those annotations from the image annotation editor. Let's have a look at one of those. So basically what you see is the class and 2 letters. FP is for false positive, FN is for false negative, and there are other possibilities. Let me show the slides. It's the report, and here you have so FP, false positive. It means it was detected by AI detection, but it was not present in the original annotations. False negative means it was present in the original annotations, but it was not detected by AI detection. And true positive means that it was is existing in both. So this is, you want to maximize your level of true positives. If you're not happy with your detector, then you should maybe revise it, train it again, and test it again. Once you're happy with your detector, you want to import your results from the detector as annotations in your mapping resource. So let's come back to TMX, and then we'll go back to AI detection. And here there's a button for import as image annotations. Again, this will open this tool, and I will press replace to replace all the annotations in my images. Normally you don't have any annotation because you just run AI detection, so you can just press add, and I can see again if I go to my image annotation editor, these are the annotations that were created. You can see it's not fully accurate because my detector was not trained based on highway images, so it's not super successful. But anyways, what you can do now with those annotations, ultimately you want to convert them to asset or to point objects. So how to do this? You need to use two tools. So first you would use image annotations to objects. It's in the extract toolbar. This is not something new, but I will show it just to complete the workflow. So basically you can just directly press start now. Oh, it failed because I selected coordinates. You need to select bounds. You can also check use center to get the center of the bounds, and then press start now. So basically what it does, it uses the direction of your annotation in the image and snaps to the point cloud to create a point. So what we can see, for example, here, this one is a bit strange, but yeah, it created a lot of points. And what you want to do is, let's take maybe this one, for example, or this one, okay. So you see it created a lot of points because there are many annotations for the same object, and now you want to cluster objects. So just use cluster objects. You can select group by attribute if you want to have distinct objects for the different classes. I will use a label ID or a label name. Press start. And what it did, now I have two additional point data sets. So this is the convert cluster. So you can see I start from a group of points and I end up with only 1 point. Okay, so it's a bit more, I mean, no, it's better. Now here I have 2 points because I have probably 2 different classes in this one. If I select those, you will see in the object inspector, yeah, this is 50 maximum and this one was no passing. So I guess the correct one is 50 maximum, so I'll delete this one. You see, there was only one that was wrongly classified, so I'll just delete it. Okay, and now that's pretty much it. You trained your AI detector, you ran the detection, converted your annotations to objects, and you're basically done. You can again use the AI, not AI, it's the tools, compare vector data sets to compare your resulting cluster. Let's say I will select source here, compare it again against your ground truth. Okay, so in this case it would be traffic signs. You can choose the compare attribute, its class, press start, and then you have here your results. And then you can quickly see which ones were correctly detected and which ones were incorrectly detected. I'll make my legend, and we can see the result on the map. So we can see none of them is green because none of them were properly classified because my detector was not appropriate for my data, but it gives you an idea. Okay, next thing, another quite interesting improvement is that you can run AI detection with scripting. So how this works, you basically need to edit this batch file here, do AI detection.bat, and edit the lines accordingly. So these are the default lines. So I will go to my software location, and I go to program bin tools, and then you will find here do AI detection.bat. You will edit this file with a text editor and then add what you need. So here is the path to the mobile mapping resource. This is the path to your detector, and this is the path to the target directory. Where do you want to save the results? Then you call tool AI detection, and you can do it for many detections in a row. That's what makes it quite interesting. And then you will just run this batch file. I'm not going to do it because it's going to take a long time, and it's also be aware that it requires a TMX license. So make sure you have enough concurrent seats. Otherwise, just make sure that TMX is closed before you start running this batch file. Okay, and this is new. One other new thing is that you can import publishers' annotations into Assets Manager, and for example, you can use those annotations for AI training. Let me show you quickly. I have a publication open here, and if I open the annotation sidebar, I can see that I already have a couple of annotations here. So let's open this one. So you see I've got these two annotations. I will move up one image and create a new one. And give it a class, no entry. Okay, that's it. I've got my new annotation. All right, then I will go back here, and I can download all photo annotations for the selected resource. So just save it somewhere. And then from Assets Manager, make sure you open the correct asset resource. It's this one here. And I will go to Edit Resource, so right click on my mapping resource, Edit Resource, Manage Image Annotations, and then as the source, I will select it's annotation file, CSV JSON, and here you choose Coco dataset from publisher, and then you browse to this Coco dataset. It's a JSON file. So that's the file I downloaded. Open. First, I want to show the AI, the image annotations I have in this resource. Okay, I've got those 4 annotations, those 4 images that contained annotations, and then I will press add to add these new annotations. Okay, so now I have this extra annotation, and I can see it here. it's not this one. Yeah, it was this one. And note that the same steps apply for reports. You know, you can report a problem, as Artem explained in the part 1. So you would run the same steps. So finally, some small but interesting improvements. The LREF XY distance is now negative when a measurement is made on the left side. So this is interesting because it allows knowing, let's say you save an object that was measured with whatever measure function, but using linear reference. So I'm going to make an example here. I'm going to use trajectory simplified and just create a point somewhere. If I create it on the right, you can see LREF distance XY is positive, but if I make my point on the left, it is negative. And this applies also in Publisher. Finally, just want to say that there is a new library of AI detectors. So the link is here, and you can see the detectors are available already. So maybe you don't need to train your own detector. We have a couple, a good, interesting list of detectors. For example, traffic signs works well. And that's pretty much it for my presentation. So thanks for watching, and if you have any question, again, don't hesitate to contact us at mx_support@trimble.com. Thank you. Bye-bye.